the Hellcat, the F6F, a single-engine, semi-low-wing combat airplane equipped for use on Navy aircraft carriers or as a land-based fighter. As the ground crew prepare to start the engine, they follow a carefully planned routine that should be understood by all pilots. After the mechanic in the cockpit signals that the ignition and starter switches are off, the prop is pulled through 3 or 4 revs in the direction of rotation to clear the cylinders. A live cartridge is placed in the breech of the starter. And after locking the breech, the mech secures the access door. Cowl flaps are open, as they should be for all ground operations. Carburetor air directs manually. The plane captain is careful to see that no crew member is on the wing stub, and that the man in the cockpit keeps his arms inside. These precautions will avoid possible injury. With engine running, the hydraulic system pressure gauge should show a pressure of 1,500 pounds per square inch. This pressure is necessary to engage the wing locking pins and operate the safety locks. After the wing folding hydraulic valve control has been set to lock, the outer wing panels are swung forward to join the wing stubs. Then the safety lock is pushed down and to the right, mechanically locking the wing hinge pins. As this locking operation is completed, the red indicating cylinder on the wing recedes until it is flush with the surface. There's nothing unorthodox in the proportions and appearance of the F6F. Likewise, there is nothing unorthodox in her flying characteristics. In fact, experienced pilots say that she flies like a trainer. At service loading, she has a gross weight of about 12,000 pounds, but her 2,000 horsepower double-row Wasp engine endows this airplane with unusual speed and climbing ability. The landing gear is sturdily built to take the shock of carrier landings, and the wheels are widely spaced to give maximum directional control. When you man this airplane for the first time, bear in mind that you are about to fly a fighter equipped with an engine which will develop 2,000 horsepower. You must have an intimate working knowledge of all her instruments and controls, and know how to get the most out of her powerful engine within the prescribed limits of operations. Use of the safety shoulder straps is mandatory in this airplane at all times. Adjust your seat so that you have proper vision through the reflector sight on the instrument cowl. And be sure the rudder pedals are adjusted to suit your leg length in order to give you full positive control. Before you leave the line, increase manifold pressure to about 30 inches and check your mags by moving the ignition switch so that the engine operates momentarily on each magneto. A drop of 75 to 100 RPM is considered normal, but if RPM loss exceeds this, malfunctioning is indicated. The hydromatic constant speed propeller should be checked at an engine speed of approximately 1,800 RPM. Pull up the prop control to the full low RPM position and observe the tachometer, which should show a loss of approximately 500 RPM. Then return the prop control to the takeoff RPM position, and if the RPM returns to its original value, proper operation of the prop is indicated. For close adjustments, turn the vernier clockwise to decrease RPM and counterclockwise to increase the RPM. In order to prevent an accumulation of sludge in the blower clutches and to check on the operation of the auxiliary blower, set the throttle to give an engine speed of 1,400 RPM with prop in full low pitch and mixture control in auto range. Shift blower control quickly from neutral to low auxiliary stage. And when instruments have stabilized, you will notice slight increase in manifold pressure and engine RPM, accompanied by a slight drop in oil pressure. A further shift of the blower control from low to high should be followed by another small increase in manifold pressure and engine RPM, but oil pressure will remain fairly constant. Be sure and return control to neutral in one quick positive move. Finally, check your ammeter to be sure the generator is charging properly And don't leave the line unless it is. And don't forget to unlock your tail wheel. As you taxi out on the field, don't exceed 1,000 RPM. Use your rudder to maintain direction and avoid overuse of the brakes. Visibility from the cockpit is excellent. There is little need of S-turning to see ahead. As you make sharp turns, try to keep the inside wheel moving a bit in order to avoid rubbing off the tread. When you arrive at the takeoff spot, let the plane roll straight forward a few yards to align the tail wheel. Go through the check-off list carefully and deliberately. Don't trust to memory. Follow the list item by item. Wings locked. The red indicator will be retracted flush with the surface. Gas tanks full, giving you a fuel load of 253 gallons. 87 1/2 gallons in each of the two main tanks and 78 gallons in the reserve tanks. Mixture control automatic winch. Blower locked in neutral. Prop control set for takeoff RPM. Electric fuel booster pump on. Cowl flaps open as necessary. Elevator tab neutral. Rudder tab 1.5 degrees right. Aileron tab neutral. Tail wheel locked. Wing flaps up. You can't gun this engine to full takeoff RPM and manifold pressure while holding the plane with the brakes. If you exceed 2,000 RPM, the tail will lift and you will risk nosing over. Start your takeoff by easing the throttle forward until you have 45 to 50 inches of manifold pressure. This is ample power to fly you off, but you can pull up to 54 inches if necessary. The F6F has very little tendency to swerve and will fly yourself off at a speed of about 60 knots. Now let's go back and try a carrier takeoff with flaps down to give a shorter run and a quick positive lift. The flaps are electrically controlled and have no intermediate positions. The control switch is pulled back to lower the flaps and pushed forward to retract them. If the electrical control fails, you can manipulate the flaps manually. Be sure the handle is depressed before moving the lever. If necessary, use the hand hydraulic pump at the right of your seat. Safely airborne, 500 feet or more, retract your landing gear and bring up the flaps. Also, switch off the electric fuel pump. If your mission demands it, you can climb for not more than 5 minutes with military power, using 52.5 inches of manifold pressure and 2,700 RPM in neutral blower. For normal requirements, however, you will throttle back to rated power or less and move the mixture control to auto lean at all power conditions except for takeoff and military power. For normal rated power, use 44 inches of manifold pressure and adjust the prop control for 2550 RPM. At approximately 5,500 feet, you'll reach full throttle. Allow the manifold pressure to drop to 41.5 inches. Throttle back 3 to 4 more inches to prevent exceeding low blower manifold pressure. Open the intercooler flaps and shift quickly to low blower. Use 49.5 inches for rated power in low blower. You will reach full throttle at approximately 15,400 feet. Allow the manifold pressure to drop to 47 inches. Throttle back 3 to 4 more inches and shift quickly from low to high blower. Use 49.5 inches in high blower to continue rated power climb. The full throttle altitude is approximately 21,800 feet. Of course, at this altitude, you will be using oxygen as needed to protect against anoxia. Watch the cylinder head temperature closely. When cruising, never let it exceed 232 degrees centigrade. 260 degrees is permissible for takeoff, military, and rated power operation. Your oil inlet temperature also is important and never should be allowed to go above 95 degrees. Keep an eye on the fuel quantity gauge too, and when operating on the reserve tank, watch for the warning light that flashes when this tank is down to 50 gallons. For minimum fuel consumption, use 1,300 RPM and 30 inches below 5,000 feet, which will burn about 40 gallons per hour. Now, while we have a safe altitude of more than 10,000 feet, let's observe the stall characteristics of the F6F under various conditions. Here the airplane is approaching a stall with power on and wheels and flaps up. There's little warning in the way of buffeting, but as the stall becomes imminent, controls will be sloppy and ineffective. At close to 62 knots, she'll stall fully and fall off. But smart, prompt action brings about a normal recovery. Now let's observe a power-off stall in the clean condition, where the stalling speed will be approximately 65 knots. The nose comes up and gets very heavy. Response to controls is sluggish. She shudders a little and falls off. But again, normal recovery is brought about by the usual methods. With landing gear extended and flaps down, a power-on stall will occur at about 53 knots. There is very little tendency to spin if prompt action is taken to regain control and recover normally. For a power-off stall, with wheels and flaps down, the stalling speed will be close to 58 knots. Again, no adverse characteristics will be experienced, and the usual technique of regaining control brings about prompt, normal recovery. The behavior of the F6F in dives is largely dependent on good pilot technique. Her stick forces are fairly light, and response to all controls is quick and positive. There is no dive checkoff list, but the required preparations are simple and easy to remember. The throttle is retarded to give 15 to 18 inches of manifold pressure, and the prop governed for 2,000 RPM. Cowl flaps closed. Rudder tab a few degrees left. Elevator tab neutral. After you push over into the dive, adjust your tabs as may be necessary to maintain your flight path. Don't let your speed touch more than 390 knots indicated, and don't exceed 7 Gs under any loading condition. Make a smooth, easy recovery to guard against blacking out, and also to avoid putting undue strain on the airplane. This airplane is not restricted and may be flown through such maneuvers as the slow roll, which is entered at a speed of 170 knots, is entered at 190 knots. The Immelman entered at 200 knots. As you come in for a normal landing, go through the checkoff list with deliberation and care. Tail wheel locked. Fuel on best tank, in this case the reserve. Mixture control auto rich. Prop control takeoff RPM position. Flaps down. Landing gear extended. But don't do this until your speed is 110 knots indicated or less. There's nothing tricky about the landing characteristics of the F6F. Bring her in with a little power at about 80 knots indicated. When you have the runway under you, cut the gun and set her down for a good 3-point landing. She'll touch at 60 to 65 knots. Let her slow down somewhat before you use your brakes. Then you can bring her to a full positive stop without heating them up unduly. Now let's watch a field carrier landing. Make your approach a little slower than for a normal landing, about 75 knots. But keep your eyes on the signal officer, not the airspeed indicator. When you get the signal, cut the gun and let her hit the mat. In a real carrier landing, you may hang on the wire and bounce, but your oleos are built to take it. When you are ready to taxi to the apron, pick up your wing flaps and open the cowl flaps fully to keep cylinder head temperature within prescribed limits and prevent scorching the spark plug elbows. As soon as you have wheeled into your parking spot, the plane captain will give you the signal to cut the engine. Advance throttle to give about 1,200 RPM for 30 seconds. Then move the mixture control lever into idle cutoff. As soon as the prop stops rotating, cut your switch and wait for the plane captain to call out, all clear. Call out to the plane captain, switch off. Finally, shut off the fuel valve, turn the battery switch to off, and cut all other operating switches before leaving the airplane. As this picture has demonstrated, the F6F has no adverse flight characteristics. She is relatively easy to fly, and her armament packs a real wallop. Appropriately named the Hellcat, this airplane is known to be a match for any adversary, a fact already proved by the results of actual combat.